In this video, we are going to go over one question. What's the difference between the root mean square and the cumulative root mean square when you're performing a random analysis with MSC Nastran? Now, I'm going to be referring to the MSC Nastran Dynamic Analysis User's Guide. We're going to go to this section that talks about how the CRMS is actually calculated. Here on the left is the same document, but on the page that defines the root mean square. So this will tell you what the difference is. But here, just to quickly tell you what the difference is the following. So the root mean square is calculated across all the forcing frequencies that you've defined for your random analysis. So if we define 100 forcing frequencies, the root mean square error is calculated across all 100 forcing frequencies. Now what the CRMS does, it calculates the root mean square for the first n frequencies. So say you wanted to know the CRMS at F3 as an example. This will calculate the root mean square for forcing frequency 1, 2, and 3. And now what if you wanted to know the forcing frequency or the RMS up to forcing frequency 50? So this would calculate the RMS for F1, F2, F3, all the way to F50. So that's what the CRMS is. It's basically the root mean square up until the forcing frequency of interest. So now we need to confirm this with an actual Nastran example. So if you look in the Nastran documentation installation directory, you will find this bulk data file, random-xyz. We are going to go ahead and use this file to confirm our statement that we did a moment ago. So here's that file. Let's go ahead and output an H5 file, hdf5 out. Now, this first example is going to output the psdf. And here, this next file is going to output just the CRMS. So let's go ahead and open this file, and let's make one modification here. So we're going to go ahead and update the acceleration and the stress command. We're going to say, hey, don't output psdf, output the CRMS, and then save the file. And now we're going to run both of those files. So let's go ahead and run Nastran for the first and the second file. And now let's go ahead and open the F06 file for the CRMS version, and let's go ahead and look for RMS in this file. So at the very bottom, we get told what the total RMS value is. It's it looks like it's about 10,000 or 11,000 here. So if we look again for the value in the F06 file, you see the value is also listed as the last value in the acceleration vector, if you will. Now, again, the RMS value is going to be equal to the RMS for all forcing frequencies. So that's why you see it here. Now, let's make a modification here. Let's suppose that instead of going from 10 to 1000 hertz, like this example does, and you see that, I believe, here. So you see the forcing frequencies range between 10 and 1000. Suppose I go from 10 to 500. Let's save that and rerun this. So now the root mean square is going to be calculated from 10 to 500 hertz. So if we look in this file, let's go ahead and open this file again. RMS. You see that the RMS value is different, and that's because it's calculating it from 10 to 500 hertz. And if we look for this value again, we see that it's here in the last line of the range of forcing frequencies. So if you look here, the corresponding frequency is 500 hertz. And again, we're looking at the CRMS value. So this confirms the statement we made a moment ago. The CRMS is basically calculating the RMS for the up to the given forcing frequency. So if you wanted to know the RMS for F3, this is basically the RMS for the first three forcing frequencies. If you wanted to know the CRMS up to forcing frequency 50, this is basically the RMS for the first 50 forcing frequencies. And yeah, that's basically what CRMS is. Now, I wanted to leave you off with one last thing. You are going to need a tool to build these plots very quickly. So if we look at this example, let's go ahead and look through this documentation. So the example we were talking about today is basically this example. It's enlisting 8.1 plate with psdf output. They have a plot here, but oftentimes they don't tell you the tools that they use to create the plot. So for the next part of the video, you actually get to see me how to create these plots. Now, the first plot we're going to create is the psdf plot. So what you do is the following: you open the Sol2 web app, which is free to students, engineers, and researchers. If you go ahead and go to the HDF5 Explorer, you can select the H5 file. Now we're going to select the first H5 file. This first H5 file has the psdf output. So this is what we're going to do. We're going to go to acquire dataset, select the acceleration dataset. Once we have the data, let's click on create plot. Now what this is going to do, it's going to create a new plot for you. So now we want to find the plot of interest. Now here, the next thing I want to do is maybe change this to a log format. Let's go ahead and turn off some of this data here. And then let's go ahead and jump to a different data set. I just want to make sure I'm getting the right data set. Oh, I'm looking at the wrong component. So right now I'm looking at the data for the first component. I want to look at the data for the third, or Z component in this case. And then I want to do this just for node 111. So this is going to be your psdf plot. And then if you look here at the documentation, you can see that it's basically the same plot. Now, one very important thing that you should do, whenever you make a plot, always confirm it with the data that you see in the F06 file. So here, what I want to look for is the acceleration vector psdf data. And right now we're looking at it, the data for grid 105. But I want to look at this data for grid 111. So basically what we're going to do is look at the last point. So at 1000 Hertz, what should be the value? So here I get told it's about 59,000. And if we look here, we'll go to the last point, and it is 59,000. If you look here in the far right-hand corner, it's 59,000. If I wanted to, I could also download a CSV file. Let's go ahead and open that in Excel. And then if you take all these rows, select them, you can go ahead and build your plot in Excel if you wanted to. So let's go ahead and do that real quick. Now, one thing you have to do in Excel, you have to format the vertical axes. So it's using the log scale. And it's basically the same plot we had a moment ago. And remember, if you hover over the last point, we should get about 59,000. So that's how you quickly create the psdf plot. And remember, the HDF5 Explorer is free. Now, what about the CRMS plot? It's the same thing. Here, what we did is we created a different bulk data file, and we added the CRMS command. Now, the reason we did this is because of the following. When we use psdf in that command, it output the psdf values to the H5 file. And then when we use the CRMS command, it output the CRMS values to the H5 file. So that's why we're using separate files. Now, we're going to repeat the same thing. We're going to take the second H5 file that contains the CRMS values. We're going to upload it. And we're going to go to the same acceleration data set. So let's go ahead and select the acceleration data set. Let's go ahead and create a plot. Go to the last plot, add it. And now let's make sure we're looking at the third component. Let's go ahead and turn off some of this data. Let's go ahead and just display the data for node 111. So this is the CRMS values. Let's go ahead and do a quick confirmation. So the last CRMS value is 11,000. So if we go back in the F06 file and we are at the CRMS values here, let's go ahead and look at the last value. And let me reopen the F06 file. Let's go ahead and find that plot again. So here's the acceleration vector CRMS plot data. And if we go to the last forcing frequency, we look at the third component, we see the CRMS value is 11,000. So this confirms we're looking at the data that we actually wanted to. So the first plot, this is going to be your CRMS plot for node 111. And then the second plot, this is going to be the CRMS plot for node 111. And like before, if you wanted to, you could download your data to Excel. Here you see we have a CSV file, and like before, you can go ahead and just select the rows, go to insert, and create your plots, and then select exactly what you want to display here. So here I want to display just the CRMS for node 111. Okay, so I think that sums up the answer to the question, what is the difference between RMS and CRMS? Here in this text, it's basically the answer I just gave you. What I'm going to do is I'm going to copy and paste this answer, this text, in the video description below. So that's it for this video, and thank you.